Hello everyone, we will solve this today's LeetCode problem. The question is LeetCode medium. Let's see what the question is asking. So question is a spiral matrix 3. Let's see. So we have the question is you start the cell R start and the C start of an rows and columns, grid facing east. The northwest corner is at the first row and the column in the grid and the southeast corner is the last row column, right? So basically it is representing the top top left corner cell and the bottom right corner cell, right? You will walk in a clockwise spiral shape to visit every position in the grid. Whenever you move outside the grid's boundary, we will continue our walk outside the grid but may return to the grid boundary later. Eventually we reach all rows into column spaces of the grid. Return an array of coordinates representing the position of the grid in the order you visited them, right? So we need to move in the clockwise spiral shape to visit every position in the grid. And one thing is to note that it is something confusing like this, right? Whenever you move outside the grid boundary, we continue our walk outside the grid but may return to the grid boundary later. Eventually, we reach all rows in the spaces. So this is very bit confusing, right? But if we see this example, if we see this example, we have started from 1 4, right? So one is at this second row, which is because we have started from 0. So one is at second this position, and 4 is at this one, right? This one, if you see the cursor, this one, right? So this is started from here. So when you move till 2, see this 1 to 2, 1 4, then 1 5. After this, below this, right, clockwise is, so clockwise moving means left, then right, sorry, the left, sorry, right, right, then bottom, then left, and then top, right? This is the clockwise direction, right? This is the clockwise direction. So basically what is happening here, that when we are moving to 1 to 2, right, when we move to 1 to 2, below this, right, below this 3 is available, right? So we can simply move that, right? We can simply move, so we move in after 1. So 3 is here, then we 4 move 4, but 1 is already visited here, so can't move in opposite upper direction, right? Till left, some everything is fine, but when you try to move in top side, one is already visited, so we don't need to visit it. So we will move further it 5, then 5 is not visited, and now we can move further it, right? So when we go to 6, 6 is visited. When we try to move in the right side again, clockwise for clockwise, so one is already wasted, so we will move to further top position, which is 7, and now we can move in the right direction itself. Then 8 is moving again, the below side, which is 1, is already wasted, so we will move to till 9. Then we, now after 9, this 2, the below 2, is already wasted, right? And we need to move in spiral. So that's what the meaning is, that if whenever you move outside the grid boundary, we continue our walk outside the grid. So basically it's something like that. If after 9 it can move to opposite direction, outside the boundary direction, does it, it means, like, just you imagine, like, imagine that just imagine like that this is a big matrix, right? This is a big matrix, infinite matrix, and you move to outside the boundary of cell, outside cell, outside cell outside the boundary, right? Cell outside the boundary. And after completing the spiral movement, you come enter along in this cell, right? Imagine this, there is a matrix which is outside this, after this 9 2 3 10 17, and you move in spiral, and you come back after traversing all to this matrix, right? So just imagine it as a sub matrix of a matrix, right? Of a matrix, right? Just imagine like that, and you will get to know that how it is moving, right? So basically, after first reading this question, I thought of that it will move completely uh, in all the cells, but it is something like, uh, if you see the whirlpool, right? If you see the whirlpool, it started from middle and move again and again, go on and go on and get bigger, right? It is something like whirlpool, right? it it gradually increases, it gradually increases its size, right? casually increases its size. It is something like that, right? It moves, it increases its length. This is spider, this is spider will increases its length one by one, right? One step by step, right? Step by step, right? Step by step. So if we see here how this spiral will increase its length, so one thing is clear that after moving, you see 1 2, right? If we see the first example, after moving from one is the this length, in this matrix, this is the one is the element, right? Or I can write also position, but position is bit difficult. I will write just element because all the numbers are unique here, right? So after moving from 1 2, if you see 1 2, then 3 and 4. So 1 2, this is moving only one, this this moves only one time, right? This moves in one time, right? From 1 to 2, only one times it moves, right? Now from 2 to 3, from 2 to 3, it also moves one time, in one time. Now from 3 to 5, right? See, if you see here 3 to 4, uh, if move to 3 to 4, it will move one time, but it will not able to go upward, right? Because one is already visited, so I need to move one further step, I need to move for one further step. So 3 to 5 it moves, this moves, this moves two types, right? In two times, right? Right. Same for from 5 to 7, because 5 to 6 is already 6, after one is already wasted, so it cannot move in the right direction. So 5 to 6 in one time, but we can't move in one direction, so we need to move further top, right? So 5 to 7 in two times, right? Now one last to see that from 7, right? From 7 to right, I need to move in clockwise, so I will move from to right. So from 7, if you see 8 is 8 can be moved, but one is already wasted, so I can't move bottom. I will move further step, which is 9. So 9 in 9, 2 is already wasted, right? So we can't do that, we can't stop at here 9. So we will move further, but if you move further, this boundary is uh, I will need to move in outside the boundary, right? And when I move to outside the boundary, I will move in some imaginary spiral matrix and come back, right? Come back, and after how many times I will come back? After three, after three many times. Why I'm saying three? See, 9 is wasted, right? 7 8 9 is already wasted, so 1 2, and after this, right? After this till 9 I cannot move in 12, right? So I need to move further up. So how many times it need to further? So it needs to move, this needs to move, this needs to move three times, in three times, right? In three times. And also if you see from uh, so basically this is left, this is right, this is moving right, this is moving right, then clockwise direction, which is right, bottom, right? This is the bottom, this is bottom. Then we need to move bottom, then we will need to move left, and then we will need to move top, right? This is the something. And then again we need to move right. So if you see some observation, if you check for some observation from 9 to, from 9, now from right we need to move bottom, right? And if you see bottom, this 9 comes to this 10, this 9 comes to 10, which is in three moves, 2 3 and 10, right? This 9 comes to 10, this 9 comes to 10, which is the moves is three times, right? In the bottom. So one thing you observe the pattern, this is something like right bottom one time, left top second time, right bottom three times, again left bottom, it will again four times, four times, four times for left top, right? For left top, left top, right? So basically what is happening here, what is happening here, it is maintaining a pattern, it is maintaining a pattern. We are, we can observe a pattern, we can observe a pattern, we can observe a pattern. Forget about all things, you just focus on this pattern, how it is moving, right? Forget about all the things. This is just a starting point. This is starting point. Starting point. Right. This is starting point. Right. Now what if you observe the pattern? This is something like right bottom one times, left top second time, again right bottom three times, again left top four times, and so on and on. Right. So on and on. It is just like that. That so what is the pattern? Every direction, each and every directions, I need one times to stop. Right. I need one times to stop. Right. It is just like that. Right. So what is happening that each and every time for each directions I need to move 1 1, then 2 2, then 3 3, just like that, right? See, for right, for bottom, one direction. So each direction, sorry, every two direction, after every two direction, after every two direction, moves are increasing. Moves are increasing. Right. See, when we move right to bottom, after this one move increases left top, then we again move after this two, one moves is increasing, then moves again increasing. So basically after every two direction moves are increasing, right? And it can be possible, it can be possible that cells can go out of boundary in any direction. So we will we will insert only that cells, only that cells which are inside the boundary, which are inside in the boundary. Insert only that cells in our answer, or take, right? We will take only that cells which are inside our boundary, inside the boundary, right? So basically after two direction moves are increasing. So how we is the same now, the same pattern is very simple, right? You just need to implement this, that how will you implement it, right? So one thing is to clear that for moving left, for moving left, if you are at RC, for moving left, what do you do? You will, for left you will increase, you sorry, okay, just take it as left, right, top, and bottom, right? So basically from moving left you need to decrease its column, right? So basically 0 minus 1, right? You will decrease its column c minus 1, and row will be the same, right? For right, what you will do, you will increase its column. For top, moving in top, you will decrease its row and column will be same. And for bottom, row will same and column will increase, sorry, row will increase and column will be same. It is something like, if you can't, you can write it like 0 comma minus 1, 0 comma plus 1, 1 minus 1 comma 0, and same as 1 comma 0, right? It is left, right, and top, bottom if you want to move in RC, right? So we will use this in our implementation. And for, if you just observe that each and every direction, after every two directions the moves are increasing, right? After every two directions moves are increasing, right? So we will remember that, and then we will implement it, right? So let's just start implementation. So rows is number of rows and columns is number of columns, and r start is starting point, right? So we will okay, and one thing is to note that we need to store the cells, which is, we need to store the position of the cell, right? So this is the answer which we will store. The first is the position, which is r start. So r start, and this is c as a c start, right? This is the starting position. Now what we need to do, one thing's to clear that this count. So I will start iterating in whole matrix in spiral form. So till when we will start, we will move to rows into columns, that if the count is less than rows into columns, we will iterate in this. Otherwise, if rows into columns is equals to count, we will break this loop, right? Now how will we move? For every two directions moves are increasing, right? So the first moves are at 0, right? Direction would be at 0, right? For every two direction moves are increasing, right? So for every two directions, right? If direction is, I will tell you why I'm writing this. At every two directions, moves are increasing, so I will increase it moves, right? Fine, right? Now, after every two directions, for after each iteration, I need to increase change this direction, right? So I will move till this move, right? For each direction, right? For each direction, I need to move this for each direction. For right and bottom, I need to move this moves times, right? So I will move this move time. What I will do, I will just increase and decrease according to the direction, which is either right, either bottom, or the left and the top. And one thing I have told you like this, right? For the left, you need to move back, right, right. So what we will do, I will just generalize this. How will I generalize this? I will just write like this, 4 2. So one thing is that we are moving from right. Just copy paste this here for purpose. So first thing is to right. For right going, row will be not affected. For left, this will be 1 comma 0. Sorry about bottom, right? For left, this will be 0 comma minus 1, and for top, this will be minus 1 comma 0, right? And this will be go into this. So this is the direction. First direction is right, then bottom, then left, and then top. And this direction, which is D, just representing that one. If D is 0, it means it is moving in right. If D is 1, it is moving in bottom. If D is 2, it is moving in left. And D is 3, it is moving in top, right? So the first now is D is 0. It means it is moving in right, which is correct. So this moves in one time, right? So what I will do, I will just go till R and C plus direction. So basically, that's why I have generalized this. And for each and every direction, I just need to assign this value according to this, right? If it's moving in direction according to this direction, because there can be only four directions: right, bottom, left, and top, right. So if you is moving right, we will increase this by one. Yeah, increase this by one. Now, it can be also possible that it goes out of bound condition. So I will just check first that it is inside the bottom conditions, then we will just insert it, right? So C would be the column, and if this is possible, if this is going, then I will just store this R and C in my answer. Like, one thing to note that I don't need this count, right? Because every time when you increase this count, this answer size is also increasing, right? So I can write like this also, answer dot size, right? We don't need this count. We don't need this count. I will remove it, right? So I will increase it now. After this, after each move, I need to increase I need to change the direction. First direction is right, then I need to change the direction. So direction would be D plus 1, and this direction can go further 4. So I will just take a modulus of 4. Okay, now you have understood that why I have taken D modulus 2, because it can be possible that, because I need to increase the move for every two direction, right? I need to increase the move for every two directions. So what I've done, if D is equals to 0 or 2, 0 when it becomes 4, D is become 4, it means if it is a uh, if it is at every two directions, so it is when it comes 4 or 2, it will increase its length. And if it is greater than 4, it will back to the 0 1 2 3 4, right? It will generalize to 0 to 4. It is, it will start from 0, it will go from 0 to 3, and this will move from 0 to 2. This is 0 and 2, okay? For every two directions, For every two directions, I will increase its move, and for every four directions, I will change the directions. This is how we solve this question, and we will just return an answer for this. See, this is very. You think that after this, looking this, it is very simple implementation, but for thinking this implementation, we need to observe all the things, and implementation is just a bit difficult. Something going on. 0 to 3. Okay, this there should be semicolon. Mm, time limit exceeded. Okay. Why time limit exceeded? D plus 1. Answer C0, C columns. D0 and D1 direction is changing. Okay. So D will be changed. Answer dot size. Uh, 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 I think answered is not, because while loop is here. So I think while loop is giving some errors. Right, moving in right, column will change. Bottom row will change. Left column will change. Okay, left for column will change, and the top will be row will be changed. Right. So this is correct, I think. Uh, okay, okay. One thing is to note that I have not inserted the starting row, which is R start and R start, right? I'm just starting from the next part, right? I'm just storing this next part, right? I've not started stored in the starting point, which is R and right. This is R and C, right? I need to just store the right, and I think this will be correct. Yeah, that's what it is, not going less than that, right? Let's submit it. Yeah, we have passed all the test cases. So basically, it's just an observation, and this implementation can be hard if you don't uh, if you don't make your mind that how will you implement it. It can be going hard, but if you do it like this, generalize the things, you will uh, successfully implement it, right? So hope you understand it. Okay, time complexity, right? Time complexity is so just imagine, like, we are moving in for each directions, we are moving out of boundary, right, for each direction. So for a particular row, for a particular row, till how many till how many till how many moves I can uh, till how many moves I can change directions. It can be just it will be it will be the maximum of the rows which is present, right, which is present, because for each and every time I am moving one plus move, right, from previous one, for each two directions. So for particular row or for particular column, it will maximum can uh, go out of boundary in a particular move, either the length of row or column, which is which will be the maximum, right, which will be the max, right. And for it can possible that for each row you need to move a whole spiral to traverse the whole matrix in an engineering matrix, and that will be one plus move. So basically it will be like O of max into the length of R, which is rows, and this can be the columns. And for each rows and columns, it can go to maximum of uh, the each for each and rows, it can go maximum of double times, right. So it can go to max of again rows and columns, because we are moving in a spiral form, right. And how I can analyze that how many times it can go out of boundary and move back. So that would be one plus move from the previous one, right. It can not be greater than one plus move, and it can be only till this number of rows and the maximum of columns, right. See, if you traverse only for 5 in particular right direction, so for left direction you can for left direction you can move to 1 plus move from the previous one, and which cannot be greater than the rows or columns which is in the matrix. So that why, and for each matrix it can go to the iterate in the rows and columns. So that would be max of rows into columns, or you can write it like this: O of n square, right. O of n square, right. If n is the maximum of rows and columns, right. This is something which you need to understand, right. So just imagine that we are moving for every time one plus move, and the moves cannot be greater than the rows and the columns, right. And the space complexity would be, so for returning answer, we are taking an answer vector. If you would consider this as an extra space, so O of n squared of O of m into n, otherwise O of 1, right. So O of rows into columns, if you consider the answer vector, considering the answer, otherwise 1, right. Otherwise 1. So this is how we solve this question. Hope you understand it. And yeah, thank you so much. Bye.